So in this video, we're going to take a look at the balancing method of solving equations. And as we've already stated in a previous video, we need some opposite operations in order to do this. And that's going to help us to undo certain things that are happening. And we just need to remember the golden rule written down in front of us. Whatever you do to one side of an equation, you must also do the same to the other side. So now we've understood that, let's take a look. Now, in these first six examples, I'm sure that many of you will be able to spot the answer straight away. But let's just build up this understanding of this particular balancing method of solving equations. And that way, when it gets more complex, you'll have a way to do it. So let's start off by looking at x plus 2 is equal to 8. Now, we are going to move around things in this equation by doing the same thing to both sides. And the idea, our objective, is to get that x on its own. So we can see that we're adding 2 to it. So what I want to do to both sides is to do the opposite. I want to take 2 from both sides. So if I do that, then I'm going to be left with my solution. I'm going to be left with that x still. And then on the right-hand side, I'll just be left with a 6. Now, the reason for this is because if I have x plus 2 minus 2, well, it's disappeared. I've got nothing to add to it at all. So there's nothing there to write. And then 8 minus 2 is 6. So, of course, and think about it, what is it I add to 2 to make 8? Well, of course, the answer is 6. And you can see that method really works. Okay, let's try another one. So what about b? So in this case, I've got x minus 4 is equal to 3. Now this time I have a subtract 4. And so I want to think about what is the opposite operation from a subtract 4. And of course, it's going to be to add 4. So we're going to add 4 to both sides. If I do that to the left-hand side, well, my minus 4 and my plus 4 are going to cancel out. I'm just left again with x. On the right-hand side, 3 plus 4 is 7. So my answer is x is equal to 7. Okay, let's carry on. Let's do c. Well, in c, we have 3x is equal to 12. Now, this is harder to spot because the sign isn't there, but you should know by now that 3x means 3 times x. So if I want to do something that is opposite to timesing by 3, I'm going to need to do a divide by 3. So if I have 3x and I divide by 3, then that is just going to leave me with an x. If I do 12 divided by 3, I'm going to have a 4. So I've found the solution to this equation too. X is equal to 4. Let's move on to D. So in D, we have x over 2 is equal to 7. So we can see that is sort of code for x is dividing by 2. So if I know that x is dividing by 2, I need to do the opposite operation to that. So I'm going to have to multiply by 2. So if I multiply by 2, I'm going to have x on its own on the left, because dividing by 2 and timesing by 2 is just going to cancel itself out. And on the right-hand side, I'm going to have 14. There's my answer. X is equal to 14. Now, we're going to start making it more complicated now. Let's take a look at E. So E says that 2x plus 5 is equal to 11. So let's think about this very carefully. The x is being times by 2, and then we're plussing 5. So we need to undo those steps in order to leave x on its own, and the order is very important. The first thing that's happening to that x is it's timesing by 2, and then we're adding 5. So the first thing I've got to do to get rid of this stuff is to undo the 5. I'm going to take away 5 from both sides. If I do that, I'm not going to have my answer yet, but I'm just going to be able to say that the 2x is definitely equal to 6. Because if 2x plus 5 is 11, that 2x must be worth 6. Now is the time to do the next step. We're going to divide by 2. So we're going to divide both sides by 2. X is equal to 3. There's my solution. So in this thing, I had 2 things acting on the x. So therefore, I had to do 2 different steps to find my answer. Now, the final example of this, okay, let's have a look at f. F is particularly challenging. So we've got 3 minus 2x equals 7. Now, in this example, we're going to get more confident with our algebra. We're going to play around with this a little bit more, and we're going to move things in the easiest way to find the x. I could even add the x to both sides itself. I've got -2 there, and I don't like using negative numbers too much. So what I'm going to do is I'm actually going to add 2x to both sides. And you might think, well, that's not going to help me solve the equation, but it's just going to help us to order things in a little bit more productive way. So if I add that 2x to both sides, well, I'll just be left with the 3 on the left. And on the right, I'm still going to have that 7, but I'm going to have to write a positive 2x there as well. Now I'm going to take away 7 from both sides because I'm trying to isolate that x on its own. So I'm going to take away 7, take away 7. So 3 take away 7 is -4. And I'll just be left with the 2x on the right-hand side because I've already got rid of the -7. Now I want to divide by 2 because I'm still trying to get x on its own. So I'm going to have -2 is equal to x. Now I'm kind of finished there. It is standard practice to write the x on the left-hand side. So I will. X is equal to -2, but it helped me to move that x to the right first and then move things around afterwards. Okay, so hopefully this has helped you to understand how to solve equations with this idea of cancelling out operations and balancing equations by doing the same thing to both sides.